Hello, everyone. Good morning, good afternoon, or good evening, depending on what time you're watching this video. Now, we have already finished matter. What are the different types and what are the changes in matter? Now, I am just going to review matter with all of you. It's gonna be short, but we need to remember all of them because on Thursday, we are going to have a short quiz. Isn't that exciting? It's not a test, it's just a quiz so that I know if you have been listening or not. By the way, I did put a homework on Google Classroom. I hope you have made your homework. Now, let's start our review about matter. Are you ready? Let's start. Matter. Okay. It's them again with their big butts. Matter. What is matter? Okay. That is the first question we need to answer. What is matter? Well, matter is anything, anything that has mass and takes up space. Matter is anything that has mass and takes up space. Now, does that mean that everything around us is matter? Of course not. That is not true. Matter is anything that has mass and take up space. Some objects don't even have mass, so they cannot be matter. Like, for example, fire. Remember when I asked the question, what is fire? Is it solid? Is it liquid? Or is it gas? Do you remember that one? What is the correct answer? It's neither. It's not a solid. It's not a liquid. It's not even gas. It's simply a chemical change. Now, we will talk about chemical change soon. But first, let's continue about matter. We said that matter must have mass. Well, in Earth where you live, mass and weight are almost exactly the same. However, there is a big difference because you see, there is a little thing called gravity. Gravity pulls things back down to the ground. That is why when you jump, you just come back down to the ground. Now, because we live in Earth, we can say that our gravity is one. One, because this is where we start. This is our basis, okay? Now, the problem here is the moon, Jupiter, even the sun, they don't have the same gravity as us. So how will it affect them? Well, let's say that I, teacher Kent, let's say I'm 60 kilograms. My mass on Earth is 60 kilograms too. And it's the same with my weight because the gravity on Earth is times 1 multiplied by 1. 60 multiplied by 1 is 60. However, when I myself decide that I don't like teaching anymore, I will become an astronaut and I go to the moon. When I go to the moon, my weight is no longer 60 kilograms. It will become 10 kilograms. You will become less heavy on the moon. That means you can jump 6 times higher because the gravity on the moon is 6 times lower than the Earth. So if you, let's say you jump 1 meter on the Earth, You can jump 6 meters on the moon. That's amazing, right? Yes, it's amazing. Your weight changed. However, your mass did not change. And that is the difference between mass and weight, class. Mass is the amount of matter in an object. No matter where you are. Let's say teacher Kent again, I am 60 kilograms. My mass is 60 kilograms. When I go to the moon, do you think my mass became 10 kilograms? That means I suddenly become smaller or thinner? No. It just means that my weight is less because it has less gravity. But I am still the same. The mass is still the same. The amount of matter is still the same. Next, takes up space. What is space again? Space is the volume or the area where a person or an object occupies. Remember my simple example, class? The one that we call dancing chairs. Let's say your classmate, let's say Iko and Suanoy are both dancing. There's only one chair left. And when the music stops, pak, let's say Iko was able to sit down first. So Suanoy cannot sit down anymore on the same chair because the chair can only hold enough space for one person. And if Iko is already sitting on it, Suanoy cannot sit on it too. Do you understand, class? Okay, let's try another example. Let me just think. What else? What else? How about when I put a book on top of a table? Let's say the table is very small and you put a book on top. You cannot put another thing on top of the table because the book already occupies the table. Do you understand? Let's continue, okay? So that is the definition of matter. But we know that there are 3 stages of matter. We have the solids, the liquid, and the gas. Okay. Now, the solid molecules, if you look in a microscope, the atoms, the smallest part of matter is atom, just like your classmate whose nickname is Atom. Okay, the smallest part of atoms, they are very close together, class. They are so close that it's hard to cut it. If you need to cut it, it will break down all of that matter in that area. You need to break down the matter. And because it's so close, it has a fixed shape. The shape is fixed. You can change the shape, but basically, if you let it alone, it is the same shape. Next is the fixed weight. The weight is fixed. It does not change if you put it in another area. Now, what are examples of solids? How about books, cars, erasers, even pencils? Those are examples of solids. Let's go now to the second phase of matter, which is liquid. The liquid, unlike the solid glass, they do not have fixed shape. Instead, they copy the shape of whatever they are in right now. If you put water on a circular shape, it will copy the circle. If you put it on a box, it will copy the shape of the box. However, like solid, they have fixed weight. So you know if it's 1 kilogram here, when you transfer it, it's the same 1 kilogram. That is because the atoms are a bit farther than the solids. The forces of the atoms in the liquid is less strong than those in the solid. Examples of liquids are Coke, soda, water. What else? Juice. Those are examples of liquid. Finally, the third phase of matter is the gas. Remember the gas? The gas do not have any fixed shape, no fixed weight. But teacher can, that means that it's not matter? No, it's still matter. You know why? Because of the air we breathe. We cannot see the air, but we can breathe it in. We can breathe in oxygen. That means that there's matter there. That means it's a gas. Just like the same with balloons. There's air there. When you pop a balloon, you don't see the gas, but you know there is something there because the balloon is popping or there's something inside the balloon. So what are the examples of gas? Nitrogen, oxygen, and carbon dioxide. They are examples and they do not have fixed shape and no fixed weight. Okay? Good. Now, let us continue to the next part, which is the physical and the chemical change. Let's watch a video first. Okay, everyone? I'm going to share the sound. Hopefully you can hear it.
From the air.
Okay, I think I shared the wrong video for a second. Don't worry, don't worry.
Welcome to Moo Moo Math and Science. In this video, I'd like to talk about physical and chemical changes. Physical changes are changes in appearance only. A new substance is not created, and chemical bonds are not formed or broken.
Okay, the first part is the physical change. What he said is true. Physical change, nothing new is created. It's just the appearance. It just changed shape, changed weight, but it's still the same. That is physical change.
For example, take this stack of paper and wadding it up into smaller pieces is a physical change. It still has the same properties as the original paper.
That is right. When you crumple up a piece of paper, it's still paper. It's just changed the shape. It didn't change much, only the shape.
Cutting someone's hair is a physical change.
Cutting someone's hair, it's also a physical change. When you cut somebody's hair, it's a physical change, class. Because the hair is still there. It just became shorter.
Because the hair has the same properties as the original hair. Phase changes are physical changes. When ice goes from a solid to a liquid to a gas and then back.
Phase changes, meaning it changed stages of matter. It changed from solid, liquid to gas. Sometimes it's chemical, sometimes it's physical. However, when in terms of gas, water turning to ice and ice turning into water, it's merely physical because it's still the same. It's still water. It just became solid and it became liquid.
Those are physical changes. Most mixtures are physical changes. For example, mixing.
Most mixtures are physical changes. So if you mix some things, it's usually physical change. Let's go to chemical change.
Chemical changes, on the other hand, create a new substance.
That's the most important part. Chemical change makes something new. Okay, it creates a new thing.
It involves breaking or making chemical bonds between atoms. Chemical changes leave behind clues or indicators. Here are 5 indicators of a chemical change.
So chemical change leave 5 indicators that something happened. Let's see what are the 5 indicators.
First, if you see burning or fire.
That's what we talked about. Remember, class? Burning or fire. It's a chemical change. So if you burn something, if you cook something, it's probably a chemical change. Next.
A temperature change without heating or cooling.
Oh, a temperature change without the use of heating or the aircon or fire. So it's a chemical change. If it suddenly changed temperature, it suddenly became cold. Next is,
Third, an explosion.
oh, if something explodes, class, that's probably a chemical change. Next,
Change in color is a chemical.
oh, color change. If there's a change in color in an object, it's most probably a chemical change, unless you personally made the color change. Okay, you added something to make it colorful. It's still like, let's say there's a paper and you color paper blue, it's turned into a blue paper. It's not a physical change, it's not a chemical change, it's a physical one. And finally, we have,
A change in odor can be a
okay, a change in odor, a change in smell is an indicator of chemical change. And that's it. We're gonna have our quiz this coming Thursday. I hope you guys are ready. Don't worry, it's very easy, and I will try to make it as fun as possible. Till next time, goodbye.